Hi everyone, welcome to my YouTube channel, and today let's talk about problem 5. This is very popular interview question, and the popular approach for this problem is using dynamic programming, and that's how I did it when I first solved this problem. But I was able to come up with another way of solving this problem, and that is using two pointers. So let's look at this problem. Here is our problem. I want you guys to try this problem before we look at my solution together. When I first tried this on my first try, I used dynamic programming to solve this problem, but I was able to find a much simpler way to solve this problem, and that is using two pointers. I really like my second approach because it was really simple. So let's take a look at this, how I solved this problem using two pointers. So the key to this problem is that there are two ways to build a palindrome, and I have case 1 and case 2. So case 1, we start with a single letter that's like any letter, then that letter itself is a palindrome, right? So Q is a palindrome. You can have, say, like A itself is a palindrome. So Q is a palindrome. Now, to build a palindrome that is longer than this one, you have this guy, right? You add two same letters to its left and to its right. So we have AQA, and this is a palindrome. And you do the same thing here. You add same letters to its left and to its right. So you have BAQAB, and that is a palindrome. So notice that we are building this palindrome from here, like something like this. For the second case, we start with two letters that are the same. So QQ, you add the same letter to its left and to its right. So we have AQQA, that is a palindrome, and BAQQAB, and that is a palindrome. That is the insight for solving this problem. And we will be iterating this string S from the first position all the way to the last. And then for a fixed index, we will find two substrings where we will build two cases. We start with one letter and then find out, and so we will find two substrings based on these two cases. Look at this letter S. So we have A, B, B, A, E, A, and the longest palindrome would be this guy. So that would be palindrome. But so how should our code looks like? So we will be iterating this entire length from 0 all the way to length of S minus 1. So this is key. And we build two cases. So we have fast and slow. Fast corresponds to, say, case 2, where we start with two letters. Here you can see that we have I and I plus 1. Right now, I haven't defined what our is palindrome nested function is, but this is basically, so our is palindrome will be something like this. Say we have left and right, and we will have a while loop. So we have while some conditions are true, we decrement left by 1 and increment right by 1. So what should be our condition here? We know that left cannot be less than 0, so left must be greater than or equal to 0. And we have and right guy. Right guy must not be must not be bigger than the length of S. So we have right, and that should be less than or equal to n minus 1. And we have, and what should we have? Well, we should have S of left must be equal to S of right. Okay, that's it. When we exit the while loop, what should we return? We should return, what do you think? S of left plus 1 and right? So we have this, so this means we will be getting left plus 1, left plus 2, all the way to right minus 1. Okay. So that's our function for that nested is palindrome function. And we have, so this guy, fast one, we start with two guys, right? So we have I will be left, I plus 1 will be right. So in this case, when I is equal to 0, we have fast to be what? It should be is palindrome, and then we have 0 and 1, right? and we look at this A and B. String of left, in this case 0, is not equal to string of right, which is 1, right? Fast, in this case, would be what? What should we return? Exactly, we shouldn't return anything, right? So it should be an empty substring. And how about the slow one? Well, slow will be is palindrome 0 and 0. So, well, A is a palindrome, right? We increment left, we increment right and we decrement left. But left here is already 0. So when you decrement left, we get left is equal to -1. So we exit the while loop and we return what? We return s of, here left was -1, but we have to add 1 to it. So left becomes 0. So we have 0 and right is what? Right is 1. That will give us s of 0. That's how you do this. Yeah, I think that's it. So we have a max function here and we will be keep updating our answer. And so max, and here in Python you have this lambda function, and here we should be comparing the length. So we have key equal lambda, say x, colon, and something like length of x, and that should give us the right answer. So let's write a code for this and see what we get. So this is my code for this problem, and here we have, this is our, so when we are given a string that has only one alphabet, then one letter, then we just return it. Or we also check if the entire string itself is a palindrome, and we check that by having this. So either case we return s. Otherwise, here we have a nested function. So we have while left is greater than or equal to 0 and right is less than or equal to -n-1, and s left equals s right. One thing I want to emphasize is that like the order here is important. So if you put s left, whether that is equal to s right, before left is greater than or equal to 0, then this code will not work. So that's something that you have to keep in mind. And then we increment right and we decrement left, and then we return s, and pay close attention to this +1, right? And then we'll be iterating this entire string from 0 all the way to n-2. We have this fast pointer that's corresponding to the second case where we start with 2 letters and then we build palindrome, like we check whether that is a palindrome. Slow pointer, that's for the case 1 where we start with a single letter and then we check, see if we can find a palindrome that is bigger than that. And then here we have an answer. We take the max function, and here I have a key equals lambda where we are comparing the length of this guy, and then we return answer, and that should be it. And let's run this code. Alright, so not bad, right? 99.03%. I think this method is faster than dynamic programming. And well, time complexity is, what do you think that is? It's just O n square. So yeah, that's it, and that's for this problem. I can try dynamic programming on this problem again. It is very similar to this. So once you understand how palindrome is built, you can solve this problem. And maybe I will like do more on this like palindrome related questions. Anyway, that's for that. Well, thank you so much you guys for watching my video. My video helps you guys like learning how to do 2 pointers, then please give me thumbs up and subscribe to my channel. Alrighty, so and I will see you next time.